Okay, separating a mixture. The goal of this lab is to look at a mixture and separate its components in an effort to describe it by percent. So just recall that a percent can be found by taking a part and dividing by the whole, multiplying by 100. So for example, just so you can kind of see what we're going to be doing, if you had a mixture of 10 grams and it was sand and salt, and let's say you figured out that there were 7 grams of sand and 3 grams of salt, that seems reasonable. We would take each part, divide it by the whole, if we wanted to know the percent of each one. And so that's basically what we're going to do in the lab. This one would, of course, be, this mixture would be 70% sand and 30% salt. So this is just an example of the type of thing that we're going to do. We're going to need to find out how much of each component is present and divide by the total to get our percentages. So what will the overall experiment look like? Well, there's 3 components in the mixture. The mixture contains a compound called ammonium chloride, SiO2, which is sand, and NaCl, sodium chloride, which we usually call salt. So each procedure of Late Night Labs will ask you to isolate each of these compounds in sequence. So what we are after by the end of this is to know, okay, how much NH4Cl is there out of the whole mixture, multiply by 100, and that will give us the percent of this first compound. And then we'll follow similarly with the SiO2, grams of the mixture times 100. And then last, we need to know how much salt is in the mixture. And we're dividing every time by the total that we start with. So if we're using 10 grams of compound, then, or excuse me, 10 grams of mixture, then we'll have a 10 here in each of these denominators. All right, we're going to come back to this after we have some information. Maybe we can stick in here. One thing to keep in mind in Late Night Labs, and any time, even if you are working in the real lab, when you try to mass a compound, you typically have a container with the stuff in it. You measure it, you know the grams. But what we really want to know is, what is the stuff? What is the ammonium chloride or the sand or the salt? How much of it do I have? That's really what we want to know. And so to find that, we of course need to know, well, the container that it's in, how much does it weigh when it's empty? So many times when we're looking at mass data, we'll need to know how much does the container weigh empty, how much does the container weigh with the stuff in it, and then we subtract these two, subtract out the empty container in order to find really what we're looking for, and that's how much stuff is in the container. So this is a technique and something you need to keep in mind when you're weighing something. You're also weighing the container that it's in. Alright, for the first procedure, you're looking for the ammonium chloride. So I'm just going to mention some things to keep in mind. You're going to be conducting the experiment in an evaporating dish. Of course, we want to know what it weighs empty. You're going to add the mixture, however much the procedure says. If it's 15 grams, then you add 15 grams, and obviously the mass is going to go up by 15 grams. Keep in mind at this time, it's a dish and it contains the entire mixture. So all 3 compounds are present. In the first procedure, you're heating, and actually the ammonium chloride is going to leave. It's going to sublime, so it leaves as a vapor, and what that leaves you with is an evaporating dish that now only has 2 compounds because the ammonium chloride has left. So if we want to know how much ammonium chloride was here to start with, we need to subtract these two masses. So we'll know the grams of this. And if we subtract the two, that will let us know how much mass was lost, and therefore we'll know the mass of the ammonium chloride. Okay, so keep in mind that would be a piece of information that we need to use right here. If we know how much mixture we started with, then we're able to do our first percent calculation. Procedure 2, you're going to follow the details of the procedure exactly, and you'll end up with, of course, some sand. And it's going to, again, be in a container. It's going to be in a beaker. And, of course, we want to know, well, how much sand do we have? I just want to know the mass of the sand. So you're also going to need to know the mass of an empty beaker. It turns out in late night labs all the beakers weigh the same. That's not necessarily the case in the real world, but we'll take these two values and subtract, and that'll tell us how much sand is in our mixture. Again, that's a piece of information that we need to know, and we'll divide it by the mixture that we started with, the 15 grams or 12 grams or however much we're working with. And a second percent can be found. And then in the third procedure, we're looking for sodium chloride. We actually are going to have in the procedure salt water in a beaker that we heat, and the water will evaporate and leave behind a film of salt. Again, we don't want to know how much the beaker and the salt weigh for our calculation. We want just how much salt is present. So again, we subtract out the mass of an empty beaker. So this is something that you're going to have to do throughout the semester when we're weighing compounds that are in containers. So it would not be reasonable, let's say, if you have 15 grams of mixture to start with, for you to say, oh, and I also had 98 grams of salt in it. Well, that's impossible to have more salt than you started with. So make sure your masses, when you get them, seem reasonable. Another way to check your work to see if it seems reasonable is to take a look at your percentages. Upon completion of all the calculations, if your data here is very good, then you should be able to sum together your percentages and get very close to 100%. If you get something very, very high, that might indicate that you have an error in one of your masses.